Alrighty, so here we are on day 2 for double and half angle formulas. I'm just going to drive one of these so you can get the idea of where the half angle formulas come from. So we looked at what double angle looks like previously. So now we're going to take a look at one of those double angle formulas. So I just wrote out one of the cosine ones and talk about where do these half angle formulas come from that you see on your formula sheet. So in the double angle formula, you know something about the original angle and you're trying to figure out something about the angle that's twice as large, so the 2 theta, or the 2 alpha in this case. What we're going to do is we're going to solve this equation for cosine of alpha. So the angle that is half as big as the other one. So the relationship between alpha and 2 alpha is that alpha is half the size. So if we just solve this equation for cosine of alpha, we're going to have the same, basically equivalent identity, but solve for the angle that's half as big, and that's where the half angle formulas come from. So let's go ahead and get this cosine of alpha solved for. So it looks like we'd have cosine of 2 alpha plus 1, 2 cosine squared. So you can do this for any of the formulas. That's kind of the idea. That's where these all come from. So we can start with the things that we know here. Then divide by 2. And we get cosine squared of alpha equals cosine of 2 alpha plus 1 over 2. Okay, then to undo squaring, we're going to square root each side. Okay, just so it matches up more with what you see on your formula sheet, I'm going to go ahead and write cosine of alpha on the left-hand side. Not that you have to, but might be easier. Plus or minus, because when we take a square root, we always have plus or minus. And then I'm going to write it this way again to match up more with what you have. 1 plus cosine of 2 alpha all over 2. And if you look on your formula sheet, you have something that's very similar to that. Let's just see if you can figure out what they've replaced or what they changed. I want you to focus your attention on these two angles again. So the angle on the left is the one that's half as big, alpha, as what 2 alpha is, and it's totally fine to leave the formula this way. It doesn't look so much like a half angle formula though, so see if you can tell what they did to represent that to make it look more like a half angle formula. So if you take a look, what I did is I rewrote now instead of alpha and 2 alpha, now I have half of alpha and 1 alpha. Well, this angle over here, this alpha over 2, is still half of what alpha is. So it's just a little bit easier way for people to recognize the half angle formulas if it looks like it's a half. So the big idea in these formulas is whatever you have on the left-hand side, whatever this angle is, it's half as large as the angle that you're representing underneath the radical on the other side. Now, if you wanted to prove the sine half angle formula, you would use the cosine relationship, the other one. So cosine of 2 alpha equals 1 minus 2 sine squared alpha. If you solve that for sine of alpha, you will get the half angle formula for sine. And then to get the tangent of the half angle formula, what you do is you take the formulas for sine of the half angle divided by cosine of the half angle. So that same relationship we talked about before for tangent with the double angles, you can do the same thing for the half. So I'm not going to spend the time to do that, but that's where they come from. If you solve this relationship for sine of alpha, you get the half angle for sine, and then we just do the ratio of the sine over the cosine to find the tangent, and you come up with then, if you take a peek at the next slide here, all those formulas for the half angle identities. So there's the sine of alpha over 2, cosine of alpha over 2, and again, when you square root, plus or minus, and then tangent comes from taking, again, this expression divided by this expression will give you that expression. So that's where tangent comes from. Now that tangent one, I mean the sine and cosine are bad enough, right? You got radicals, fractions, tangent's almost enough to put you over the edge. So here's what some people do for that. They rationalize the denominator, and then because you end up with cosine squareds and sine squareds, there's actually 2 other versions of tangent that people find much easier to deal with, and you will see them on your formula sheet as well. So let's talk about those. One looks like this, sine of alpha over 1 plus cosine of alpha. And then the other version, this is all from rationalizing the denominator, doing substitutions. 1 minus cosine of alpha over sine of alpha. So if those are easier ways, and I would sure think it would be, no radicals, you don't have to worry about plus or minus, because when you rationalize and get rid of the square root, you no longer have to worry about signs, the plus or minus. It will be the value it needs to be based on what alpha is, so it works out really well. So we work with these formulas in the same way. So if we know something about this original triangle that has alpha as the angle, or we know some special value angles alpha, then we can figure out something about the triangle that has the angle alpha over 2. So we can do a lot of the same sorts of things that we did when we did double angles and even sum and difference. So we're just going to practice a few of those and to see what that looks like. So this triangle should look familiar to you. This is the same exact information that we were using in the half angle or the double angle formulas. We have a quadrant 1 angle, theta. So I'll go ahead and draw myself a quadrant 1 angle theta, where the sine, which is opposite over hypotenuse, so 2 over 5. And if you look back, I believe it was square root of 21, right? We would have 5 squared equals 2 squared plus x squared. So 25 equals 4 plus x squared. And it looks like 21. Remember the plus or minus here as well. So when you're trying to figure out your other side of the triangle, remember you have to think about signs. If you weren't in quadrant 1, you'd have to adjust the sign accordingly. So think about what's positive and negative where. Okay, so now let's look at our 3 options for tangent and talk about which one might be the best to use. I would say most people avoid the radical one unless you're really excited about radicals. So let's focus our attention on the other 2. Think about which ratios you have to use. Sine is a nice ratio, 2/5, easy. Cosine, not as great in this triangle. Cosine is going to be square root of 21 over 5. So think about which of these 2. Make your choice. Which one do you think would be better? And let's think about why. So I'm going to have to divide in the top one by 1 plus cosine, which means I'm going to have to get a common denominator with a thing that has a radical and multiply by the reciprocal, and guess where the radical ends up? On the bottom. Not pleasant. Look at the second equation though. There's a sine of theta on the bottom, and I'm going to multiply by the reciprocal. Those are integers. That would be a lot easier. So I think my best option for this one is to do 1 minus cosine of alpha over sine of alpha. For me, that would be the easiest arithmetic. You can do it the other way. It's not wrong if you don't, but it's just a whole lot more arithmetic. It's much more likely that you're going to have issues with arithmetic if you do it that way. Oops. So for this one, we would have 1 minus cosine over sine. So 1 minus cosine, the cosine ratio would be square root of 21 over 5. And then the sine ratio is 2/5. All right, so let's get our common denominator here and go through and do what we need to. So we're going to get a common denominator of 5. So think of this one as 5 over 5. So I'd have 5 minus the square root of 21 all over 5. And I'm going to divide that by 2/5. So 5 minus square root of 21 over 5 times 5 halves. And then I'm going to divide out my common factors. And it looks like my tangent formula for half that angle would be 5 minus the square root of 21 over 2. Okay, now I want you to think about this. This angle alpha we knew was in quadrant 1. If you take half of an angle that's in quadrant 1, what quadrant should you end up in? Half of any angle in quadrant 1. Well, if you take half of any number in quadrant 1, something between 0 and 90, it's still going to be in quadrant 1, right? Even the tiniest of angles, like an angle of 1 degree, its angle, if you take half of it, would be half of a degree, still in quadrant 1. So this should be a positive answer because tangent would be in quadrant 1, and it most definitely is because square root of 21 is less than 5. So I think we're good. So we have something that's reasonable, but definitely easier arithmetic, right, to do this than it would be to try to do the other formulas. All right, let's try another one. Now, the first one was very much like what we did before. We looked at information about a triangle. We could write ratios. Life is good. You can also do what we did back in sum and difference formulas when we were trying to express things that aren't special value angles using some formula that we know something about another angle. So let's see if we can take a peek at, first of all, what the heck is this? So 7 pi over 8. I know a lot of you don't like to deal with radians, but we'll kind of talk about this both ways so we know what angle we're talking about. 7 pi over 8 is the half angle. So this is the half angle that they're talking about. So this is the one that's half as big that we don't know anything about. So this is the alpha over 2. So if you double it, theoretically that is some angle that you know something about. So the entire angle alpha then would be 7 pi over 8 doubled, right? So times 2, which would be 7 pi over 4. Now, does that angle sound like something that's familiar to you? Well, sure. 7 pi over 4, that's the same as 315 degrees. It's in quadrant 4. We know a bunch about that. So you can do it in radians, and actually it's pretty easy to double an angle in radians. Actually, almost less arithmetic than if you change it to degrees. But just so you can see what you would do in degrees, we could figure out what pi over 8 is. Remember, pi is 180. This is only if you want to deal with it in degrees. So that would be what? 16, take away 2. I could have 2 more. 16, take away that. Bring your decimal, bring down the 0. Looks like it's 22 and a half. So 7 pi over 8 is the same as 22 and a half. So this is saying the same thing as the tangent of 22 and a half degrees. Now, you definitely don't know anything about the tangent of 22 and a half degrees. But remember, that's your half angle. That's alpha over 2. So alpha then would be that angle doubled, which is 45 degrees. And that is something that you know about. So when we take a look and think about what these angle measurements are and how we'd be able to deal with them, it makes it a lot easier to be able to figure out, oop, I forgot to times this by 7. Oh, whoopsie. Let's go back and do that. It's 22 and a half is what the pi over 8 is. Sorry about that. I have to times it by 7 then. Whoops. Okay, so 22 and a half times 7, not a super fun one, but that's where we get the 315. Sorry about that. So this angle doubled then. Oh my goodness, what am I saying? The doubled is 315. Trying to go too quickly here on a weekend recording. So we'll double this. I'll go through. So times it by 7 because there's 7 of them, right? So that would be 14, 15, 16. Carry the 1. 14, 15. So 156.5. That's your alpha over 2. When you double 156.5, we would get... Let's see. Did I do my arithmetic right here? 14. Oh my goodness, 157.5. I should just start over here. This is crazy. 157.5. So that's 15, carry the 1, and that would be 11. There we go, 315 degrees. So my alpha would be the 157.5 doubled. So you can see there's a lot more places where you can mess up your arithmetic, right? It's probably a lot faster just to do it as a radian measure, but it doesn't matter. The whole idea is the angle that you're given is the half, and the angle that you're trying to find, shouldn't have said that as 22.5. Should have been this. It's the tangent of 157.5. Make sure you get that switched. I forgot to times it by 7. Those two are saying the same thing. They're the same value. They're the same expression. So whichever you think is easier, leave it in radians, change it to degrees. But the whole idea is, okay, I only know something about the double angle. So this is the half. If you double it, then yeah, I can figure out some information about that. So again, we have 3 different options for that tangent formula. Most people, again, I think like to have the least stuff in the denominator, depending on what else you're dealing with. So I think I'm going to go back probably and use that same bottom formula again. I don't think that there's going to be much to do to avoid having radicals because that's just what those values are going to be. So they have less in the denominator might be a little bit easier. So I'm going to go ahead and say my tangent value for 7 pi over 8, or if you'd rather, your tangent value of 157.5 is equal to, and use that bottom formula, 1 minus cosine of 7 pi over 4. This is the double angle, or you could say of 315. I'm going to write kind of both of them. They could be either one, but you're using the angle measurement for double the angle, because remember, this is your half, and then this is going to be your alpha. So you know something about that alpha angle. And then on the bottom, we're going to have sine of that same angle. So sine of 7 pi over 4. Or if you'd rather 315, doesn't matter. So what you know is you know the double. You know the angle that's twice as big. We're trying to figure out the half angle from knowing that information. So whatever angle you're given, we double it, and that should be a special value angle. All right, so let's put in those values. 315 or 7 pi over 4, that's a 45-degree reference angle, which means cosine and sine are both square root of 2 over 2. But cosine would be positive because you're in quadrant 4. Sine would be negative. So that's what we've got. Now we have to just deal with the arithmetic then. So let's go ahead and multiply through and do what we need to here. So we're going to try to see what we get for that. So multiply by, let's see, 2 over 2 for this one. Get a common denominator. So 2 minus square root of 2 over 2. divided by that. Now we're going to multiply by the reciprocal. So times 2 over negative square root of 2. These 2's would divide out, and that's going to leave us with 2 minus square root of 2 over negative square root of 2. All right, now we got to get rid of that radical on the bottom. For AP testing, we wouldn't have to worry about it, but for working with it, let's multiply top and bottom by square root of 2. We're going to rationalize. So we have to distribute on the top. So that looks like what? 2 square root of 2 minus square root of 2 times square root of 2 is 2. A whole lot of 2's down here. And then divided by negative 2. Square root of 2 times square root of 2. Last thing, let's simplify out. Divide everything by negative 2. So it looks like it would be, maybe I'll put negative square root of 2 plus 1. Or if you'd rather, you could say 1 minus square root of 2. Either one of those would be just fine. And that would be the value for the tangent of 7 pi over 8. So what we did is we doubled that angle. This is the half angle, right? The 7 pi over 8, or 157.5. We used the double, or the angle that was twice as big, because we knew something about that. So the whole idea is in a half angle formula, you're trying to figure out the half. You know the one that's twice as big, and you're able to get that exact value. All right, let's try one more of those so you can see how that half angle thing works. So we have sine of 112.5. Clearly not an angle that you know anything about. That's your alpha over 2. What you need to do then, and I think a lot of people like this because it's in degrees, you have to double that to figure out alpha. What angle are they thinking you might know something about? So 112.5 times 2 doubled, well, that's 225, and sure enough, that is definitely a special value angle. So that's something that we can use to help us find the value of sine of half of it, that 112.5. All right, so let's take a look at the sine formulas here. Sine and cosine are a little bit trickier to work with, so I'm just going to go copy, the formula with just the alpha in there first. I think I'm going to do that so you can see the whole formula on this one slide before we start. So sine of alpha over 2 is equal to plus or minus square root 1 minus cosine of alpha all over 2. Okay, so let's talk about how we decide things. First of all, the plus or minus comes from the quadrant that the alpha over 2 angle is in. So when I look at this alpha over 2 angle, it's the original. It's what you're trying to find the answer for. 112.2 is in quadrant 2. So that means in quadrant 2, cosine values would be negative. So if I was trying to find the cosine of alpha over 2, I'd have to pick the negative. So I would be picking negative. But it's sine of 112.5 in quadrant 2, so that means I'm going to be selecting positive. You have to choose the sign. There's no way that you're going to be able to figure that out any other way. You have to know what quadrant is the angle in that you're trying to find the answer for. So you're looking for sine of 112.5. Okay, so that's the first issue. Got to figure out your plus or minus. Now, we're going to go ahead and substitute in this information then into the formula on the other side for this 112.5. That's your alpha over 2. That means underneath it's the cosine of 225 then. It's the double angle that you use because remember the relationship between those two angles. Whatever this one is by itself, the one on the other side is twice as big. That's your alpha. So that's the one that you supposedly know something about, right? We know something about cosine. All right, so this would be big square root 1 minus, okay, cosine of 225 is square root of 2 over 2, 45-degree reference angle. It's in quadrant 3, which means cosine would be negative. So that's minus a negative. So be careful. When you're putting in ratios, you have to take into account then when you're substituting in the sign of that ratio. All right, so keep going. Think of that 1 as 2 over 2. You're going to see this arithmetic a lot. It would be plus positive, so plus square root of 2 over 2 over 2. So many 2's, the crazy 2's. All right, so now 2 plus square root of 2 over 2. We're going to multiply by the reciprocal. So think of that as your 2 over 1. So that would be times a half. So big square root, 2 plus square root of 2, all over 4. Now, there's really not a whole lot you can do here to simplify. However, I can do this. the numerator and denominator of a radical can always be evaluated separately. So I know I can't do a whole lot with the top, but the bottom's a 4. That's a perfect square, so we can call that a 2. Works great. So we have that sign value is positive 2 plus square root of 2 all over 2. Now on your graphing calculator, you could check this really quickly. You could type in sine of 112.5, see what you get as a decimal, make sure you're in degrees, and then try that radical and put in this expression, and you will see that this exact ratio will give you the same decimal approximation. So we have this way to find these other values. That's just fantastic. Okay, so I'm going to finish up here with just one last example. I'm going to do it on this part of the video so we can see what's happening with these one more of these cosine ones, so we can kind of finish that up. Then for the next part of the videos, the next section, I'll do all the verify ones. Okay, so let's talk about cosine of 5 pi over 12. So again, this is the angle I don't know anything about. This is your alpha over 2. Really easy when it's in radians. Try to keep it that way if you can, because I think it's faster. We need to double it or times it by 2 to figure out what alpha is, the angle I can actually use, and that would be 5 pi over 6. For me, this is a lot easier than doing all that other arithmetic. But 5 pi over 6, that's definitely an angle we know that's the same as 150 degrees, definitely a special value. Now, if you're really freaked out about the radians and you don't want to double it and that freaks you out, we can do the 180 divided by 12. Hopefully I won't mess up my arithmetic this time. That would be 60, that would be 5. Great, and then 15 times 5. 5 carry the 2, 75 degrees. Okay, so that's your alpha over 2, 75. That's your half angle. Clearly not a special value angle, but if we double it, then it would be 75 times 2. There's your 150. So if you'd rather do it in degrees, you sure can. Now, we've seen 75 before. We've actually done that question, but we did it as a sum or a difference. Remember how we wrote it as 30 plus 45? Well, here's a situation where we could have done an alpha over 2 as well. So you can do it as half angle also. Okay, so the first thing that I'm going to do is go ahead and write the formula again. So this is the cosine formula, plus or minus. It's 1 plus cosine of alpha over 2. Okay, and again, let's just run through this again to make sure that this makes sense to you. The plus or minus part out front comes from the quadrant of the original alpha over 2 angle. So that original alpha over 2 angle, that's how you tell if it's going to be positive or negative. So our original alpha over 2 was 75 degrees, or 5 pi over 12, which means we are in quadrant 1 for the original angle. Okay, so that means it's going to be a positive answer. This alpha over 2 gives me a positive answer. Now, if the quadrant for the original angle would have been 2 or 3, so cosine in quadrant 2 or 3, then I would have chosen the negative. So it always goes by the original angle, because that's what you're trying to find the answer for. All right, so let's write this out. We have cosine of 5 pi over 12, or 75 if you prefer. It's going to be positive, just kind of emphasize that. 1 plus cosine of alpha. Okay, well, what's alpha? That's your doubled original angle. So when we took 5 pi over 12 and we times it by 2, or you took 75 and times it by 2, that's the angle that we're talking about, the 150 then. That's the one we supposedly know something about. And then over 2. So the sine and cosine formulas are basically identical. The only difference is one's a minus. Get it? The only difference? That joke never gets old, does it? You love it. Okay, so let's take a look and do the simplifying. So 1 plus. Okay, cosine of 150. That's in quadrant 2, which means the cosine value is going to be negative, and it's a 30-degree reference angle, so negative square root of 3 over 2. Got to know those special values. All right, now let's see if we can simplify that a little bit. Going to have to get a common denominator up top, so think of that as 2 over 2. And because it's a negative, I'm going to go ahead and write that as subtraction. You can see that the arithmetic really works out basically identically to the last one. It just said square root of 3 over 2 instead of square root of 2 over 2, but you do the same things. Be careful on your signs. You see a lot of places for arithmetic errors. All right, so 2 minus square root of 3 over 2 times the reciprocal, 1 over 2. So we get under the radical 2 minus square root of 3 over 4. And then again, just like in the last one, this cosine of 5 pi over 12, right? Yep. Would be positive 2 minus square root of 3 in the numerator. And then again, we can think of that radical as top and bottom separately. That would be over the whole number 2. So we have a way, again, to describe angles that are not special values with using an angle that is. So that gives us kind of that next piece of what we're going to be doing with half angle formulas. So in the next portion, we'll talk about verifying.